Hi everyone, it's Ian here from Crack Maths, back for another tutorial. This time we're at tutorial 47, which is how to use formulas to calculate the volume of 3D shapes. So in functional skills maths, there are several formulas that you're going to come across, some that you need to know and some that you don't need to know. In this tutorial, we will look at a couple of formulas that you're expected to know, but largely we're going to focus on slightly more complicated formulas that they don't require you to remember, but they do require you to be able to use. Just as a side note, if you are wondering and you're thinking about the formulas that you need to know and don't know, on the website crackmaths.co.uk there is a section where I've made a formula sheet and I have run through the formulas that you are expected to know by memory. So if you're approaching your exam or if you just want to get ahead of the game, it is very worthwhile looking at this document in order to memorize the formulas that you need to know, because that is going to help you no end. Right, let's get started on today's lesson though, which is how to use formulas to calculate the volume of 3D shapes. So for this topic, I would say there's three main things that you need to know. And firstly, that would be that letters in maths can often be used to hold the place of numbers. Okay, so when you see a formula, and the formulas that we're going to look at, we're going to see a collection of letters that have been written together. And when you see those letters, each of those letters usually stands for something which can be replaced by a number. So in this topic specifically, it's all about lengths. Okay, so each of the lengths, like the width, the height, the depth, all of those things are going to be able to be replaced with a number. So usually the letters are pretty obvious. It's usually L for length, W for width, H for height, R for radius. But when you see them in a formula, those letters are going to be interchangeable with the number that's on a specific shape. Okay, the second point that you need to remember for this topic, and this is key for loads of things in maths, is if you see letters written next to each other, that means that they are being multiplied together. So if you get a formula, say for example, let's say the volume of a cuboid is length times width times height, which I'm going to write here as LWH. This actually means L times W times H, okay? So that there is the formula for the volume of a cuboid, LWH. And a key hack that we're going to learn in this tutorial is that when we want to substitute into these formulas, the best thing that we can do to remind ourselves of what's going on is before we substitute the values in, we replace the letters with the times versions. So instead of writing down LWH, we write down L times W times H. And that's going to help us remember that these letters, which represent numbers, are going to be times together. Okay, the third thing that we really need to remember in this topic is about squared and cubed. So often the formulas for volume will involve these symbols. So it's usually with a radius actually, so r squared or r cubed. And what we need to know is that that too only applies to the letter that it's on. So when it's r squared, that means that this r is actually an r times r. If it was r cubed, that would mean that that r is actually an r times r times r. So you might remember from the area of a circle, if I write this down, the area of a circle equals pi r squared. Now, this formula actually means pi times r times r. Okay, so remember the symbol, that little 2 or that little 3, only applies to the letter that it's connected to, and then subsequently the number that's replacing that letter. Anyway, I'm talking too much. I think we should just go through some examples. I'd urge you to stick through with me through most of this video today, because actually we're going to progressively get more and more complicated questions, and we're going to start to look at formulas that involve fractions as well. And they're going to be really useful for you to be able to know, because sometimes the fractions can throw us off a little bit. Okay, so here we have question 1. I've started nice and easy. It says, find the volume of a cuboid with length, which I've said L in brackets there, equals 3 centimetres, width equals 2 centimetres, and height equals 4 centimetres. So I've got the volume here, the volume formula at the bottom, which says V for volume equals LWH. Okay, now, in the question, we've been given the value of each of these letters. So we can see that L is 3, W is 2, and H is 4. But before I put these values in, I'm going to rewrite the formula with the times signs. So, if the formula is volume equals LWH, then that means volume equals L times W times H. Okay, now I've done that, I can write the formula again with replacing the letters with the appropriate numbers. So we can see that L is 3, so I'm going to put 3 times, and then W is 2, so I'm going to put times 2, and then H is 4, so I'm going to put times 4. So the formula is telling us that the volume of this cuboid here is going to be 3 times 2 times 4. Okay, and we can do that on our calculator, or with one like this we could do it in our heads as well. So in fact, let's try doing it in our heads. 3 times 2 is 6. 6 times 4 is 24. And because this is a volume, the units are going to be centimeters cubed, okay? So remember, if we have a volume is a 3D space. If we wanted to quantify the size of the volume, we need to have a 3D object to fill it up with. So if we think about for area, it's squares because they're flat. For volume, it's cubes because they fill up things, okay? Anyway, so that's that question done. Let's have a look at question 2. So here we go. Question 2, straight in the deep end with a cone. But that's fine. We get these. They are something that we've got to be able to tackle. But remember, we don't actually need to be alarmed because we have the formula. We just need to be able to use it. So let's have a look. Question 2 says, what is the volume of a cone with radius 5 centimetres, height 10 centimetres? Okay, right, so there's only really 2 things to substitute in here. So let's have a look at this. So we've got the formula here. Is V equals 1/3 times pi, remember they're written next to each other, times pi times r squared times h. Okay, so let's tackle it all together with this one. So I'm going to rewrite the formula. 1/3 times pi times r times h. Okay, and now I can rewrite this with the numbers. So I've got 1/3 times pi, which I'm going to replace with 3.14. So 1/3 times 3.14 times 5 times 5 times 10. Okay, right. Now, I'm going to do the pi times 5 times 5 times 10 first. And then we're going to think about the times a third. Okay, so if I've got 3.14, I'm doing this on my calculator, by the way, 3.14 times 5 times 5 times 10, that's going to equal 785. Okay, so there we go. We've got the first part of it done. We've got the substitution part of it done even. And now we just need to times that by a third. If you want a third of something, you find a third by dividing it by 3. Okay, so for this question, if we want 1/3 of 785, which when we say a third times 785, that's what it means. We want 1/3 of 785. What I'm going to do is I'm going to do 785 divided by 3. Okay, and then that gives me the answer 261.6 recurring, which I'm going to call 261.7 to 1 decimal place. And remember, this is a volume, and these were centimetres, so the volume is centimetres cubed. Okay, so there we go, 261.7 centimetres cubed. Great, let's look at another question. Okay, right, so we went hard and now we've gone harder again. Remember, you do not need to know these formulas, okay? The volume of a cone, you don't need to know. The volume of a sphere, you don't need to know. But they have been known to crop up on functional skills papers, so you do need to know how to use the formulas. Right, so here we go. Determine the volume of a sphere with a radius of 7 centimetres. Okay, and we've got the volume formula given to us here. And the volume formula says 4 over 3 times pi r cubed. So let's rewrite this with our time signs. So this is 4 over 3, or 4/3, times pi, which is 3.14, times r times r times r. Okay, right, so let's first of all deal with this 3.14 times r times r times r. So I'm just going to do that on my calculator. So we've got 4 divide... Oh, no. So we have 3.14 times 7 times 7 times 7. Okay, so that bit gives me 1077.02. Okay, so we know what the pi r cubed is. That's 1077.02. Now we've got that value, we need to work out 4/3 of that. So first of all, to do that, we find 1/3. And to find 1/3, we divide it by 3. So 1077.02 divided by 3 equals 359.006 recurring. Now we want 4/3. Okay, right, so 1/3 is 359 point blah blah blah. And so we now need to times that by 4 so that we have 4/3. So I times this by 4, and that's going to equal 1436.02 recurring. Okay, and I'm just actually going to call that 1436 centimeters cubed to the nearest whole number. Let's say to the nearest whole number. So if you would like some more practice now at this sort of question without the involvement of any context, I would go to crackmaths.co.uk and check out tutorial 47. But if you're feeling ready to have these in a context situation, then stick with me and we can have a look at that now. Okay, right, so here we are. We have scenario question 1. And this question says, a prism-shaped pencil holder has a triangular face with an area of 12 centimetres squared and a length of 15 centimetres. What is the volume of the pencil holder? Actually, and they've... So this is interesting. I've included this one, and it seems a little bit too generous, because sometimes they do actually just give you the formulas with words, okay? So I don't want you to be thrown when that happens either. So what I've done is I have included this worded formula. So we've got the formula here, and it says the volume equals triangular area times length. And this formula is actually common for any prism. So let's have a look. We've got V equals triangular area times length. I can see from the question that the triangular area is 12 centimetres squared, and I can see that the length is 15. So I'm just going to do 12 times 15. And 12 times 15 equals 180 centimetres cubed. Okay, right. Let's have a look at another one. I don't know if this one's going to be quite as nice. Okay, here we go. Scenario question 2. A little bit more challenging, as I'd hoped. So here we go. A candy mould creates half sphere shaped chocolates. If the radius of the mould is 3 centimetres, what is the volume of one chocolate? And they've given us the formula for the volume here, and that is that V equals 2 over 3 times pi r cubed. Okay, so this time we've put the 2/3 in brackets, actually. It doesn't change anything. If you ever see a value in brackets next to a letter or a symbol, that just means that the bracket's being multiplied by the letter and the symbol as well. So that just means that we've got here 2/3 times pi times r times r times r. Okay, so I'm going to write that down actually. 2 over 3 times 3.14 times r times r times r. Now we might as well substitute in the value. So what I'm going to do here is I'm going to write V equals 2 over 3 times 3.14 times 3 times 3 times 3. Okay, now remember, I'm going to work out the second bit first, okay? And then we will worry about finding 2/3 of that at the end. So 3.14 times 3 times 3 times 3 is going to give us 84.78. Okay, So now we've got 84.78. We need to do 2/3 times that. So that means 2/3 of 84.78. So first of all, we find 1/3 by dividing by 3. So divided by 3. So we know that 1/3 is 28.26. And now we find 2/3. So I multiply that by 2. So times 2. And so the answer to this is going to be 56.52 centimetres cubed. Okay, great. Thank you so much for joining me on this tutorial. If you need any more help, any more questions, any more practice, remember that there's loads of questions available at crackmaths.co.uk, and this was tutorial 47. Okay, perfect. I'll see you in the next tutorial. Bye.